Hello, everyone. This is part two of the Precedence Networks and chapter, and we talked about the ladder type or the stair type of overlapping activities, and we said this type of approach is mainly for horizontal construction, and in the vertical construction, this is not very a practical approach. And we said if we go into break down our activities into multiple sub-activities, it'll be an overwhelming number of activities for each number. And we said if you have 1,000 activities, then it'll be 5,000 if each activity is broken down into five sub-activities. So we said this is not very practical approach to vertical construction, but it is useful approach for horizontal. So with that, we had to think of some other approach to utilize here. And because of that, we're going to talk about another approach, which is the precedence diagram method. But first, if we're going to utilize this approach, we're going to have to make a few assumptions to make our scheduling procedure easy to follow and also not overwhelming for the user and for the reader as well. So first, we'll assume all activities are contiguous. Once an activity is started, it has to continue until it finished. Previously, we used to interpret or stop our activities if other activity has to start, or they can also finish, but with some restrictions. This assumption makes the calculation easier. And then once we complete our diagram, we come back to it with the interruptible activities and add them to your overall diagram. So this approach here, or this method has four approaches. The first approach is start-to-start relationship with no lags. How does this work? Imagine, let's go back to our previous problem, the utility line from part one. And let's assume that activity A is the excavation, which has a duration of 10 days, and activity B is the bedding or the sub-base activity with the 5 days duration, and C is laying the utility pipeline with a duration of 3 days. So for the activity start-to-start relationship with no lag is that we are making all the activities, as you can see here, start all on the same day, on the same time. So we're giving them 0 starting days. The reason we marked our A activity as a critical activity from here is that it has the longest duration, which is then 10 days. The sub-base activity is 5 days, and the laying the pipe is 3 days. So then your excavation goes all the way to 10 days, while the 2 other activities, the second one, which is the sub-base, stops at 5 days, the 5th day, and the pipe laying, it's on the 3rd day. But the problem with this approach here is unrealistic, because your excavation is still going for 10 days while laying the pipe and the sub-base are finished way ahead of time, which is unpractical. So then take us to the second approach, which is a start-to-start relationship, but this time with lags. So then the same scenario we have here, and we make all of them get started on day 0, but we're giving this time lags to them. So the subbase activity won't start until the 6th day, or within the 6 days period, this activity B can get started. However, they can get started on the same time if there is an opportunity for the user to do so. But for the sake of this example here, we have the excavation start at day 0. The excavation duration is 10 days. So the yearly finish is 10 days. Then we give it a lag to B6. So then 6B starts at the 6th day with a duration of 5. Then you have 11 days for B for an early finish. And then 1 day lag for laying the pipe, and then your pipe starts at 7. So as soon as you get some percentage done of providing the subbase, then your laying the pipe activities get started. Then with the 3 days duration, you have 10 days. Now, if you notice here, we have 11 days late finish for laying the pipe, but the yearly finish is 10. So why is that? Well, as you can see here, we have a critical activity, which is B, the subbase. It's 11 days. So looking at this bar chart, the excavation lasts 10 days, and then your subbase activity has 5 days here, as you can see. And then it finishes on the day 11, but laying the pipe actually finishes at day 10. So this is still unrealistic because you still need to give extra time for the pipe to be done. So then we gave it here 11 late finish, so it can finish on the same time, which is one float date. But then this activity became uncritical, while in reality, it's actually critical, if that makes sense. So then with that, we have to find another approach. And this time approach is finish-to-finish relationship with no lag. In other words, what we're trying to say is, even if we get these activities started on the same date, we don't want activity B finishes until A is finishes. And we don't want activity C finishes until B finishes. That's solid, that's concrete. This is the way it should go. But those without lag. So let's work on this and see how it works. Let's verify the process. So then we're getting activity A starts on 0 with duration of 10. Yearly finish is 10. But B starts on the same day, which subbase, and then the duration is 12. And then C starts at 9 and finishes at 12. Now, from the Gantt chart, the subbase and laying the pipe are done both in the same day or in the same time, which is also unrealistic. Unrealistic because you still need to give extra time for laying the pipe after finishing the subbase. You know, like leveling the subbase, make sure the thickness is the appropriate thickness according to the particular specs and so forth. So all this process, you need an extra cushion for yourself to be able to get to schedule the laying the pipe and on the right time and get it done on the right time as well.